Hello everyone, this is Mr. Kozlowski. Welcome to our unit on motion. Today I will be discussing position versus time graphs. Position versus time. The learning target states that I can read and draw a position versus time graphs that appropriately identify starting position, direction, relative speed, and time. So what we have here are examples of two different position versus time graphs. And the very first thing that we need to know about the graph is the shape. So if we look here on the left hand side, we have a graph that has constant speed. And if we look, position is on the left, basically the y-axis, and on the x-axis is time. And if we look at the line here, we have constant speed being represented. And the reason we know it's constant is because the slope of the line never changes. So that means over an interval of time, it is going the same distance for that same amount of time. So for every second in this graph, it is going at a distance of 10 meters. So that is what we know as constant speed. The other shape that you might be aware of about is when we have changing speed. And in changing speed, the time intervals might be the same, however, the distance differs from second to second. So in this case, if you kind of look at the representation up here above the graph, the position goes from 0 to 2 meters, so that's a difference of 2. 2 to 8, that's a difference of 6 in between that second. 8 to 18, difference of 10 meters there, and from 2 to 3 seconds. So as you can see, the time increases, the distance also keeps increasing and getting farther and farther each second in this case. So that's what the shape of these graphs tell us. Now, when we're identifying position, we have to kind of know a few different terms moving forward. The first term is distance. Distance is going to refer to how much ground an object has covered during its motion. So if we look at this picture down here, distance is represented by the purple line. So if this is point A right here, where my mouse is, and this is point B. From point A to point B, the distance traveled in purple is the path that was taken to get to point A to point B. This is different from displacement. Displacement refers to how far out of place an object is. It is the object's overall change in position. So if we look at the same 2 points, point A, point B, well, yeah, the distance traveled is here, but the positional change or displacement, point A to point B, is the green line there. So understand the distance versus displacement, those definitions. That's key with understanding position versus time graphs. So here we have a position versus time graph, and what do those things mean? Well, we know what the shape means. Where's the position? Well, position is represented on the left-hand axis here. And so the line, as we go up, we're going to have a change in position. So if we're going up in the graph, so from here we are going from 10 meters to 40 meters from this middle line right here, this steep slope line in the middle. That is basically a positive change in the position graph. So if we're going from 10 to 40, all right, that's a positive change in distance. If we were going the opposite direction, let's say we went from 40 to 10, all right, that would be a negative change. So if this line continued and let's say it went down, that would be a negative change in position. So if we're going up on the graph, it's a positive change in position. If we're going down on the graph, it's a negative change in position. The direction of travel is essentially determined by also the line. So again, if we are going above the number line, so here would be 0, right? If we continue this graph negatively, which I never will show you, we're going above that 0. That's going to be it basically moving to the right. If it's going down, it's going to the left. So understand that the direction of travel is also indicated. I'm not going to be too worried about that, but just understand that, you have a positive change of position or a negative change in position. That's kind of the big thing. And direction of travel we'll work on more in class. Finally, identifying the speed. It's all in the slope. And what that means is the slope of the line, or what you may have in math, which is called growth rate, determines how fast the object is traveling. We can calculate slope by using this equation, but we're not going to. You need to explain in relative terms how slope of an object determines the speed. So if we look here, let's compare this point, 0 to 10 meters in the first 10 seconds. We have this slope, and if we compare it to the second sloped line here, the slope is steeper in the second line from 10 meters to 40. So when is it moving faster? Well, the rule is this: the steeper the line, the faster the object is moving, because it's traveling more distance in less time. So here, the object is traveling fairly slow. Get to the next rate, or next slope right here, the object is traveling faster. And if we get a flat line, that means it's not moving at all. So kind of keep that in mind, that the slope will determine how fast that object is moving. And basically, the steeper the slope, the faster the object moves. So to review a few things: position is the location of an object at a particular moment in time, and it's more related to displacement. Direction of travel is either determined by positive or negative positions. And slope, which is rise over run, determines relative speed of an object. We're going to be working on these more in class, but that is the basic information that you must have an understanding of for this learning target. If there's any questions, please let me know.